Okay, so welcome everyone to this new video. In this case, we are going to discuss about police. In part 1, we have discussed about 3 cases. In this video, this is the case 4. And you can see from the figure, now this is the figure. Okay, you can see from the figure that M1 and M2 both are connected by a string and which is going through a pulley. Now, the force on M1 is M1G due to the gravity, and force on M2 is M2G due to the gravity, and there is a common tension between this string that is equal to T. Now the trick is this figure can be thought as this figure when the pulley itself is not moving horizontally or vertically. If the pulley is fixed at a certain point, it is rotating, it is okay, but if the pulley is not moving horizontally or vertically, then this figure can be thought as this figure. Now when you think this figure, the problem will be more easier to solve. Now here you can see that this is the mass M1 and this is the mass M2. Now the force on M2 is M2G and force on M1 is M1G. Okay, now as the both masses are connected, so the individual forces will act on both of the masses. Okay, now just think M1G is not present here, then only M2G is present. Then what will happen? This mass will act on both of the masses M1 and M2 as this is bound by the string. Now if you ignore this force M2G, then this force M1G will act on both of the masses M1 and M2. So that's why the resultant force will act on the both of the masses. Now in this case, what is the resultant force? If I write the resultant force is F R, then you can see that the resultant force will be here M2G minus M1G. First you have to think this body together M1 and M2, and on this body two forces are acting M2G and M1G. Now what is the resultant force on these two bodies? This is M2G minus M1G. Okay, now what is the acceleration? Acceleration is mass force per unit mass, that is M2G minus M1G divided by what is the mass? M1 plus M2. Now this is the common acceleration, and you can also write like this: M2 minus M1 divided by M1 plus M2 into G. So this is the acceleration. Now let's talk about the tension. Now think of these masses only M1. Now when you think of these masses only M1, what are the forces acting on these masses? The forces acting on these masses, due to that fact, this mass will move with an acceleration A. Okay, so that's why you can write like this: the T, if the tension is T, then T is acting in right side minus M1G is acting on left side, and due to this resultant force, this mass is moving with and acceleration a. That's why m1 into a. So that is t equal to m1a plus m1g. Now just put the value of a here, m1g plus m1. What is the value of a? m2 minus m1 divided by m1 plus m2 into g. Okay, now this, by calculating this thing, you will get, let take common as m1 g, and you will have 1 minus m2, 1 plus m2 minus m1, m1 plus m2, that is m1g bracket m1 plus m1 plus m2 plus m2 minus m2 minus m1 divided by m1 plus m2. Now this m1 cancel out, and you will have 2 m2, so that is 2 m1 m2 g divided by m1 plus m2. That is, you get t equal to 2 m1 m2 divided by m1 plus m2 into g. Now this is the tension acting on the string. This is the tension acting on the string, and this is the acceleration. This is the common acceleration of this body. On the basis of this theory, so many problems can come in NEET as well as in the ISC or in the CBSE exam. So hope you understood this problem. See you in our next video. Thank you.